Hello, everybody, and thanks for joining this session for continuous network compliance. Compliance is code, and the reason I put this together is because now more than ever, it's so critical and important to protect our mission-critical network infrastructures, and not just from security incidents, but also from other anomalies that affect performance and availability. So what I'd like to do is just give you a quick level set on the current state of network compliance and some of the challenges. And I'd like to show you some examples of how we can use Ansible automation to be able to detect compliance issues faster and to be able to remove human error. And then from that, we want to build on that value and take a look at Event Driven Ansible. So you saw that in a couple of the previous sessions. And what I'm going to do is take what we've done with automation, and what I'd like to do is show you how we can move from being more reactive to being more proactive and being able to effectively detect these compliance issues in real time and be able to provide self-healing configurations for our most important configurations, or what I call our protected configurations. And we'll talk more about that. And as this session culminates into a demonstration, you'll see a lot of these things happen again in a live demonstration. So because I'm a part of North America public sector, I focus primarily on these three compliance standards with my customers, so NIST and DFARS and sometimes HIPAA. So if you're in other sectors, you may have other standards that are more relevant to your examples. But for me, it's primarily focused on these three. And because of that, I spend a lot of time helping customers understand how to protect their network devices. So in the federal space, oftentimes we're working with STIGs, and we talked about that some earlier too. So if you're not familiar with STIGs, those are provided by DISA, and it stands for the Secure Technical Implementation Guides, right? So these guides tell us what we need to protect on our devices, and then how we implement them, we can improve that level of effort using automation. So we'll take a look at that. We'll also take a look at some of the reasons why we need to comply in the first place, right? So oftentimes we have to, we don't have a choice, right? They're mandated. But in some cases we do have a choice, and we provide our own compliance standards or our custom standards or best practices because we want to. So speaking as a network engineer, I can attest to in previous roles where I spent a lot of time deploying networks and operating networks, it was always very important to me to provide a very stellar customer experience. And a lot of times there's work that goes in behind the scenes where you spend so much time in your lab environments, and you're building your guidelines around these are our baseline configurations that work, and we want to apply these configurations across all of our devices and ensure that we provide the best experience. So we may be looking at things outside of security, quality of service, focusing on availability, and also, again, on application performance, which ties back to network performance, right? So one of the things that I wanted to do is just to do a quick poll. And for those online, you may experience some lag on these questions, or you may already be able to see them in the chat. But I just wanted to gauge the audience. How many in the room are a network engineer or a network administrator that have some responsibility related to network compliance? Raise your hand. So there's a few of you. Okay, hey. And how many of you are not a network administrator that work in some other department in IT that have an application or a workload or a service that depends on the network? Raise your hands. That should be just about everybody, I would think, right? So it's probably fair to say that this third question, how many of you feel that network compliance is critical to your organization? Right, that should be almost everybody as well. So we're going to see some of those techniques. And another point here to make is that we talked a little bit about security and a little bit about performance, and then sometimes there's just those things we can't plan for, right? There's these security incidents that happen because our network devices, our firewalls, our routers, our switches, they run on software, right? So we are susceptible to these vulnerabilities that happen, and then we need to be able to react to those, right? So we need to be able to quickly apply hot fixes or potentially configuration workarounds. And to do that, it's a challenge, right? Because when we talk about network devices, we may have thousands or tens of thousands of devices, and that's very difficult to do without automation. So automation is completely critical in those situations. So some of the examples of some of these compliance specific configurations that we may need to make. This is not an exhaustive list, it's just a few samples. And two of the ones that we're going to actually see in the live demo is syslog configuration, because that's very critical from a network management perspective, and also disabling protocols. A lot of times these devices, as you rack and stack and bring them online, and even with the zero-touch provisioning, some of those configurations by default may open you up to some vulnerabilities. Right? So we want to be able to disable protocols that lend themselves to known vulnerabilities. So things like HTTP, where there's command injection and those types of things, are pretty prevalent in network devices. So we'll see that too, and that's actually a part of STIG. So you'll see a component of STIG as part of the demo as well. So here's one of the demos that I usually show that shows effectively this is a general approach to responding to network compliance using automation. And I'm not going to show you this demo because this demo is actually pretty good. So I do have the link to the GitHub repository here. So if you find this useful, you're more than free to take a look at this. This is a public repository. I also have another demonstration that's at the bottom, which is a dashboard. So it's an easy to set up dashboard so that you can visualize your network compliance and be able to track, what devices are in compliance or not, and have, red highlights as they go out of compliance. I'm not going to show you that one either, but that's a good demo as well. I'm going to show you a demo that's gooder, and that's the one that has EDA. So we're going to take a look at Event Driven Ansible, and again, we're going to be able to fix problems in real time. So that's the demonstration that I'm actually going to show you today. So Event Driven Ansible, I'm not going to double click into this, so we have more time for the live demonstration because we've already talked about it. Lee did a really good job earlier that gave you, a nice level set around how event-driven Ansible works. But what I will do is I'm going to walk you through some of the configurations just so that you have a map to see the relationship between what a rulebook is versus a playbook, and how a playbook can be configured as a role, and how we can take conditionals and logic and be able to respond to a particular event in EDA in our playbooks depending on many factors, right? So we're going to walk through that. And if this is new to you, I'm just really going to focus on the salient points. I'm not going to get into all the ins and outs of the playbook. I just want to show you some of the things that add great value by using Ansible automation, and more importantly, adding EDA or stacking EDA on top of the Ansible automation. So in this demonstration, one thing that's interesting that you may or may not have used in the past is telemetry. So on networking devices, routers and switches, and even some firewalls, you can enable streaming telemetry. And there's various protocols that you can use. In this demonstration, I'm using a Cisco router, and I'm enabling telemetry such that the router itself becomes a tattletale. So if you were to access this router out of band and make a configuration change, we want to know what that configuration change is, and we want to look at that configuration and determine if that is a configuration that we've deemed as what I call a protected configuration. So if it maps to our STIG compliance, or if it maps to our custom compliance that we set up our own baselines, then we may want to act on it immediately. But if it maps to a configuration that we just want to have, track that configuration for informational purposes, we can do that as well, but we'll respond to it differently than we will the first two. So you can think of that router as kind of like a proverbial Karen, right? So, excuse me, someone has just changed my configuration. I would like to speak to the Ansible. And that's what happens in subsequent steps here, is that data is passed to the EDA, and then we will evaluate that data through conditionals. So in the rule book that I'll show you, we will have a rule, and in that rule we'll have conditionals to say, what is this? If it's a configuration, we'll act on it by running a playbook in our Ansible automation controller. And then we'll have further conditions and decision points based on how the playbook was constructed. Now, the other things at the bottom, let me walk through that. So first, we're going to take a look at a custom check and remediation, and then I wanted to give you an example of STIG. And then lastly, I have a configuration that we don't really care about, but we want to know that the system was configured out of band, so we'll track that for informational purposes. So again, just a few more slides. to double click on how this works. So this is the how, right? We kind of talked a little bit about the why. So with streaming telemetry and with Cisco routers, there's different ways that you can configure it. In this particular example, I'm using IETF Yang data models, and I'm using gRPC that has a dial-out capability. And more importantly, it gives me the ability to update on change. So if I want to look at a router, I have access through what we call a path, or in this case, an XPath, because we're talking about IETF Yang models. I have the ability to look at all of the configuration state as well as the operational state. So in this example, I want to see that if a configuration changes, then what I want to do is point to that, and that's what this XPath is, this iOS :native. That's a generic path to the configuration. So in that payload, in that streaming telemetry, I'm going to send the entire configuration. And then we're going to evaluate that configuration to say, oh, this is an SNMP configuration, or this is a logging configuration, or this is a routing configuration. And we'll be able to determine what type of configuration it is and how we would like to respond to that. So on the telegraph side, all that is a collector. And it's just one of the collectors, but what it's doing is it's taking that protobuf, which is the format that we send streaming telemetry, and it's converting it into JSON. So we have JSON as structured data, and it's connecting, or it's integrating with one of its, what we call an output, and it's sending it to Kafka. So Kafka is a message broker, and what we're doing is we're creating a topic, and we've named it Telegraph. And that Kafka broker, we have a source plugin for EDA that listens on a particular port for that data that comes in. So the handoff here is to a rulebook. So a rulebook is just like a playbook. It's written in YAML, and it has some required parameters, and it has some optional parameters. One of the required parameters is, hey, we need to know what type of source this is. What type of source plugin are we invoking? In this case, we're invoking Kafka, which is a part of the Ansible EDA collection. And then within that, one of the parameters that we have to define is, okay, what topic are we listening to? So we're listening to Telegraph. And then what's important below that are the rules. So this is how we want to detect in the data a condition that means something to us, and then we want to provide an action. So if we look at the rules, you can see that in the condition, we're pointing to the body of the data that comes in, and to the right, you can see there's a Kafka viewer. So this is just the raw data. If you look at the arrow, the down arrow, it's pointing to name. So name is defined as Cisco iOS XE native:native. So that means that we have a Cisco configuration coming in. So that's the condition. When we see that come in, then what we want to do is invoke this action. So that's going to trigger a job template that's called EDA config check. And then that job template is the way that we manage a playbook in the automation controller, right? So it's just everything you do from a command line. If you're more familiar with Ansible, you have all those same options available to you in the GUI, the automation controller, to launch a particular playbook. So that's what we're going to do. And one of the things that we can do that's really interesting is we can pass extra variables. So we've defined one of those extra variables as config, and that's pointing back into that data, the body of the data, and it's pointing to fields, and that's where we learn what type of configuration it is. In this case, it's a logging configuration, right? So then we have that logic available to us to see how we want to react in our playbook, right? And then lastly, it's just the source, and the source points to router 1. That's just defining which router it is. So when we trigger a playbook, we want to run that if there's a remediation against router 1. We're not going to run that against every device that's in our inventory, right? It's just the one specific router in this case. So the segue into a playbook is we need to understand what are we running, or what are we matching on. So we do that, or in this case, I'm doing that with a parameter that I call a tag, and I'm defining a tag in what we call a set fact. So in that, we have the ability, and a lot of people say that, like with Ansible, you're limited, you're better off automating in Python, right? But the secret to this is that Python is Ansible, and if you want to run Python, you can simply do that in a plugin. So there's all these plugins available for us, and we use them as filters. So one of the filters that I'm using here is dict2items, and what that is doing is I can point to keys in a dictionary. And I'm only pointing to keys that make sense for my STIG compliance that I want to be able to run live. So one of those is the HTTP service, the web service on the router. I want to make sure that's disabled, so I want to watch for that. And another one is the pad configuration, and then boot P. These are just examples, and I wanted to show you that you can have more than one that you can match on. You can match on several in a conditional, and we define those as when, as the when parameter. The other one further down is logging. So I'm also running what we call resource modules for my custom compliance check. And in that one, any configuration in the module logging global starts with logging in terms of what that data payload comes in as. So anything that has the key of logging, I want to evaluate that and see what that configuration is and check in my single source of truth to make sure that that's going to work okay. Right? So in the single source of truth, in this case, I'm using YAML files, and we're comparing against that. That it could be something in terms of like a database, a CMDB database that you check against, or a system like NetBox that focuses completely on source of truth, network source of truth, right? But effectively it's the same thing. We're comparing a configuration, right, or what our policy is versus what's running on that device. And we're going to make that check to determine whether or not a configuration is in or out of compliance. So this is an example of a source of truth. And again, this is a YAML file. So the one on the left, because I'm using a resource module, it's structured data, and I'm naming that dictionary logging_IOS. And then in that dictionary, I'm defining host names. So these are the host names for my syslog servers that need to be there. If they're not existing in that configuration, we're going to add them. If we add one that's different than this, we're going to remove it. Because in the playbook, and I'll show you, I'll have the state of replace where it can add or remove, as opposed to merge where it can only add configurations in. It doesn't remove configurations. To the right, we're using this iOS config module. And what this does is it gives us the ability to pass configurations as lines. We can also run Jinja2 templates, but in this case, it's just really simple one-line commands. If we enable IP HTTP server, then we want to do a no to negate that. So no IP HTTP server to remove it. So it's pretty simple. It's either on or off. And with these protected configurations, that's what we're doing. It's either missing or it's something that we need to disable because it shouldn't be there. Now, a role is a way that you provide a playbook in a repeatable way and make it very shareable and variabilize it. So we have a very simple playbook that in the beginning all we did is we looked at set facts and we were matching on conditionals to say, okay, this is a STIG check or this is one of my custom compliance checks. Another thing that I negated to explain, and I'd be remiss if I forget this, is that if we don't match on something explicitly, then I also had the ability in a default parameter to add another category that I called other. So I forgot about that one. So if we don't match specifically, we go into other, and other would be a check that doesn't require all of the same process that we're providing to the ones that we're calling protected configurations. So here in this particular role, you can see on the left, we have this config, right? And if you recall, we're passing config as extra variables. So this is the data that's coming in from EDA, and we're able to read that in, and we're comparing that in our single source of truth, and we iterate through that in that logging iOS variable. So we're just reading in a dictionary, and if it's the same as the source of truth, we're good to go. If not, it's going to make that change, that appropriate change. On the right, it's just applying that line, and that was the no IP HTTP server. So it's using this config, iOS_config module, and that's how that one works. So when you see this in action, it'll make more sense if you're not familiar with these. And then lastly, there's ServiceNow. So what I'm doing is I'm opening a ticket, and then once we remediate the protected ports, we're closing a ticket. Now, if we were unable to remediate it, it's also important in the sense that we would be able to, at a minimum, pass data. So that data could help us triage the situation. So if you look at the description here, we're passing a lot of that same data that we've learned from EDA through those extra variables, and anything else after that we've learned from the playbook itself, we can pass that data into ServiceNow, and then that's what the operator sees when they log in to that incident. They'll have that data available for them, so they're up and running. They can hit the ground running and use that data to save time, right, to find root cause quicker. In this case, we're going to fix the issue. But in other examples that I've used in different demos, it's very important to be able to collect that triage because you can save a lot of time. I can check a lot of routers and switches through automation a lot quicker than somebody SSHing into them one by one and gathering that data. All right, so now time for the live demo. And I got to put these on because I can't see my monitor. Escape out of here. All right, and make sure that this router still reacts. All right, so let me get this out of the way. And what you see on the screen here, and let me log in. You'll observe to the left, this is the automation controller. And what we're doing here is we're monitoring jobs. So when we trigger a job template which runs a playbook, it creates a job. So we'll see that happen in real time as we make a change. To the right, we've got the EDA controller. And the EDA controller has this window where we're tracking a particular rulebook activation. And as it sees that data come in from the devices through the Kafka topic, it's going to provide that on the screen. Right, and it'll trigger the job to the left. So you'll see these things start to move, and I'll switch between screens and expand them so you can see it a little bit better. And another tool that we have is the Kafka viewer. So this is just reading in data that's coming in. Currently, you just see the status of a different router. Router 4 is just showing that its interfaces are operationally up, and it's just to show that Kafka is running, and it's just kind of there in the background. But when we make a change, we'll see that happen here as well. So I'll go into router 1, and I mentioned one of the custom compliance standards that I created was based off of monitoring the syslogs. So show run. This is the current configuration, and 1.1.1.2 and 3 are the proper syslog servers. So let's say that Bob comes in and he thinks he's in a staging environment, but he's actually pointing to the wrong inventory and he's just not as careful as he should be. So he goes in and he puts in a new syslog that doesn't really make sense for this environment. And then let's see if we can find that here. So right here in our Kafka viewer, we can see this data came in. And then on our screen on EDA, we should see that same data to the right, which we do. Let me move some of this stuff out of the way a little bit. So you can see right here, this is that exact configuration that came in. And then what it did is it started to run this job template, EDA config check. So that was over here. So this is running a playbook. Now, we have to make this a little bit bigger so you can see it. And one of the things that we want to see is if it changes, right? If it had to change the configuration. And the screen's a little, let me make this a little bit bigger here. I'm sorry?
I've noticed that, especially on a laptop, the output is very small. Very just a handful of lines.
Yeah.
Yeah,
and I had this one really blown up, so it made it even exacerbated that. So here's what changed. So what we can see is we have this built-in diff. We have the before state. So this was the current configuration that we saw in here. And you'll notice that it has commands. So these are the CLI commands that are actually sent to the device. But we're dealing with the resource module in my custom compliance check with structured data. So this was the structured data before, and you can see that entry was in there. But then after, it's no longer there, and we can see that change was true. So it went ahead and auto-remediated that because that was one of our protected configurations. And it sent this command to the router. But what we also did below this, and I'm going to have a hard time here, so you can see this incident. So we created that ServiceNow ticket, and I have to go in here so I can grab this incident, and then we'll go into ServiceNow, and unfortunately, I'll have to log in because it's been sitting here. And I want to bring it back to the main screen with the search. All right, and we're just going to search for that incident. And you can see that I was able to pass the data based off of what EDA was providing, from what came in from telemetry, and also make some comments that it was remediated. So that way we can track these things, because even though we don't have a human involved in that particular workflow, we want to track like how long something was down or what needed to change. And then that's what we've done here, because you can see this ticket is closed, right? And it shows that the system administrator worked on it, but that could be any operator that you configure in ServiceNow. And lucky for you, you're going to see even more ServiceNow moving forward in the next couple of sessions. So Todd's got some interesting things for you, and so does Sebastian. All right, so we fixed that one. And then another thing that we did is we just do a quick check to make sure that everything works. And one of the things that's important is that we don't want to keep opening up tickets. So when we do a validation, just to make sure that the config is properly configured after making that change, we want to do that for informational purposes but not run the ticket again. So there is a conditional that's in ServiceNow that is only invoking ServiceNow when changed. So I may have forgot to mention that one on the earlier slides too, or I kind of feel like I skipped that slide with ServiceNow, but that's neither here nor there. That's how it works. So I'll go back into that router, and let's make this smaller. And a lot of you are interested in, let's just show that. I'll validate that real quick. It should run it again here. So this job here shouldn't have anything that changed. And unfortunately, I'll have to make that bigger again. So it runs it the second time and nothing changed. So it's just really just a validation at that point. And if I exit out of this, the part that I'm talking about is this. And go in here. And if you recall earlier, we sent some command lines that was the serialized data. And our before and after is the same this time. It just has the .2, .3, and then the same, right? So it's just a validation. So there's no need to open up another ticket, right? So the ticket's closed out. So moving back. So I bring up router 1 again. Now this will be more of a STIG-related configuration. So we're going to match on that tag, because this is one of our STIG configurations that we had a conditional to look out for. So if I do IP HTTP server, and then let's look at these two. It'll update these and go back to jobs. And watch those. So this one just went off. And then you can see that this configuration came in, and this becomes a key. So it's going to run the playbook, and this time it's going to run the STIG compliance check, not my custom compliance check. Actually, details, output. Oh, I clicked on the wrong thing. That was the source control. We want this one. That's when it's pulling down the configs from the Git repository. All right, so that one you can see that was pointing to that key. And let's look for when this finishes. It goes through like a whole section of STIG. And there it goes right there. Here's what's changed. So pop into the JSON. And we can see that it had to send this config line, because this one's using the iOS_config module, and it sends lines of configurations. So this is how you can look at the structured, output from running that type of module. And then now that configuration has changed. And if you don't believe me, then we do show run s HTTP. Oh, what did I do here? Oh, do. Right, and you can see that those are disabled, right? We enabled it. It was like a tripwire. You enabled it, I'm turning it off. It's done. And then the last thing was a configuration that we really don't care about. Not that we don't care about configurations, but it's a low priority configuration. So just adding a description to a loopback, we really don't care so much about that, but we want to know that change was made out of band. So Ansible automates. Shows how great automation is with Ansible. And we don't want to remove that. That actually is a good description. So bring this back over here and remove you. Sorry, I should have just went to jobs and had this ready. Let me kick that off. All right, so we're running this playbook. And what you'll notice now, as this finishes, oh, that was the validation of the STIG was still running. So I got to go back to jobs. I kind of got ahead of myself. So let this finish. 18, 18, 16. No, I still have to wait for that. Some of these sections are kind of large. So even though this is only a section of STIG, it still takes a couple minutes to finish it off. But this was the second one, so this one will not have changed anything. So I should be able, I got to make it larger so I can see this. Right, nothing changed, so that was just the second STIG. And finding it, it's a little bit higher up. Oh, I know what I can do is just search for HTTP. This one right here. So changed is false. There was no need to do anything because it was already no IP HTTP server. So that explains that. Another thing that you're seeing too that I forgot to mention, since I was all over the place, is that I have Slack notifications set up. So that's what is happening here, is that we're just sending to the network operation team, the job IDs so that they can cross-reference them and have connectivity back as we go forward. So the last thing here, we go back to jobs. 820, that was the newer one, right? This is what we did when I changed the description. So we just had to wait for the one job to run and then, subsequently the second job ran. And this one is saying these changes on router 1 were made at this timestamp, but not enforced as part of a compliance rule. And it shows that it was an interface description. Ansible Automate shows how great automation is with Ansible. And it was just for informational purposes so that everyone can see how great Ansible is. So that's the end of the demonstration. So again, the first one was my own custom compliance check. Then we looked at STIG, and then we looked at a configuration that was not a protected configuration. So with that being said,